Hello everyone and welcome. My name is Eric Coleman with IIST and I will be the moderator for today's webinar, Improving the Test Process with Measurements by Al Sorkowitz. We're excited you're able to join us today and set aside an hour to attend this webinar. This webinar is one of a series of free webinars to introduce the topics as well as the presenters of the upcoming SQTM conference in San Diego, California, September 13th through the 18th at the Sheraton San Diego Hotel and Marina. The conference focuses on advancing the test management and quality management professions by providing practical methods based on best practices. The ongoing theme of the conference, Practical, Proven, Feasible, keeps the focus on what works. To view the conference program and more information, visit www.qualitymanagementconference.com. Be sure to join us for the next webinar in the series, Risk-Based Testing, What Does Strategy Have to Do with It, by Clynese Cheney on April 2nd from 11 a.m. to 12 p.m. Central Standard Time. To learn more about this and other webinars in the series, go to www.qualitymanagementconference.com. This webinar is being recorded and will be made available for viewing within 48 hours at www.qualitymanagementconference.com. I will now turn the webinar over to today's presenter, Al Sorkowitz. Al?
My name is Al Sorkowitz and welcome to this webinar. Just take a glance at this warning sign and then we'll just continue. Topics we're going to be talking about today are how a world-class organization uses measurements to improve its test process. Then I'm going to have a few words on measurement. And then we're going to have examples of two measurements. And then the system test progress measurement. And then we're going to talk about a second measurement used in the testing phase, the incident tracking measurement, incident tracking or problem reports, and then we're going to end up with a summary. So let us continue. Take a look at this. This is an overview of an organization's use of metrics to improve the test process. And this is data from Siemens Corporation, a German firm, one of the largest engineering firms in the world, with about 60,000 American employees. And Siemens was always noted as one of the leading, in Europe, software developers in process. So here is some data from Siemens. And what we have here is the life cycle requirements, design, code, system test, and field use, operations. And along the rows we have what part of the life cycle the fault originated, where did the fault originate, and then the second one is what part of the life cycle did the fault determine. So when the fault was put in and when it was found out. And then the bottom row is cost per fault. So again, let's go through Siemens data. Siemens says 10% of all their errors, the fault originated in the requirement phase. Yet when they finished the requirement phase, they only found 3% of the errors. So with all their audits and reviews, they are now going into design with quite a number of requirement faults. And Siemens data shows that if they find a fault in the requirement phase, they can fix it in the requirement phase, and it only costs 1 KD. K is 1,000, D is Deutschmarks, which was the German currency before euros. And since they started this thing long before they went to euros, they kept the conversion in Deutschmarks just to show clearly. So now we're going into design phase, and Siemens says 40% of their faults originated in design phase, yet when they left the design phase, they only found 5%. So now we're having a problem. We'll be going into coding with some requirement errors and some design errors. And again, Siemens data shows that if they find the design flaw in the design phase, it costs 1,000 Deutschmarks to find and fix. Now we're in the coding phase. Remember, we have requirement errors, we have design errors, and Siemens says 50% of their errors originate in the coding phase, and with all their walkthroughs and audits and reviews, On average, they only find 7%. So we're going to be going into system test with requirement errors, design errors, coding errors. And Siemens says if they find a coding error in the coding phase, it could take only 1,000 Deutschmarks to fix. Now let's take a look at system test, an example. Siemens is finding, and this is not unusual, 50% of all their errors they're finding in the system test phase. Now there's nothing wrong with finding all the errors in the system test phase. The only serious problem is it's now cost 12,000 Deutschmarks. So if you found it in the requirement phase, it would be 1K a pop, and all of a sudden it's now 12K a pop. So it's very expensive to find errors in the system testing phase. In fact, well, we'll be talking about that in a minute. And now in the field use, when they go operational, Siemens is saying they're finding 10% of all the errors after they've gone through a system test and are now in operations, whether it's 1 day after or 1 week or 1 month or years. 10% of all their errors in the life cycle come after they go operations. And take a look at this. To find and fix an error, Siemens Data shows it costs them 20,000 Deutschmarks to find and fix an error. So we're going from 1K a pop if you find it here, to 12K a pop if you find it, to 20,000 Deutschmarks in the field use. When Siemens saw this data, they were surprised, they were shocked, they had no idea, and they came up with a goal. And the goal is to cut errors in the system test finding to no more than 10%. That's their goal. And cut this down to 5%. Now, how do you achieve that goal? You don't just send out a memo saying you will find no more than 10% in the system phase. What they have is a software process improvement group, and they go and evaluate the requirement phase, and they say, is there anything more we can do in the requirement phase to find them here, which is only 1K a pop, and is there anything more to do in the design phase, which is 1K a pop? Much, much cheaper to spend resources here than resources here at 12K. The whole tradition, the whole process in the last 25, 30 years in software development is to find more and more errors up front where it's cheaper to find and fix than to pay 12K a pop and 20K a pop. So that's how these metrics were used to find out what they were doing, how good was their life cycle development phase, and where was it costing more money than they thought. But let's bring about this. Siemens was noted as one of the top corporations, and they have this data. Let me ask you, how many of you are in organizations that have this data that's available? Normally when I give my seminars, no more than 10% of the attendees belong to organizations that have this data. So if you don't have this data, you're not too sure of what's going on your life cycle, or you're doing it so perfectly you don't really need it. But again, very few organizations have this data. And I think as we get more and more mature as development organizations, more and more organizations should have this data. And by the way, this is corporate history. That means it's available to everybody. Let's bring up another problem with that Siemens found. With 50% of the errors found in system test, that means that in systems test there's a lot of rework. If you're finding 50% of the errors, you're doing a lot of rework. Now let me ask the managers and the people who work in the system test phase, when you budgeted time and when you budgeted for time and resources to finish the system test phase, did you budget enough for 50% rework? Usually you didn't. Usually you fuzz it a little. But here, if you have some idea of how many errors you're finding, that may influence the schedule of your system test. Without knowing this, you may find you have more rework, which puts the schedule for system test problematic. Okay, so again, this is Siemens Data. The main thing is, the important thing is, they have the data. The thing that was surprising to them is that 50% was found here at 12K a pop, and 10% of the errors were found in the field at 20K a pop. Okay, let's continue to the next slide. Now, when I say measurement or metrics, I'm really talking about measurement and analysis, the whole story. And then we have to ask ourselves why we measure. And we measure because without data you only have opinions. There are very many opinions, and there's very little action you take when you have conflicting opinions of what's going on. And then part of measurement is not just measuring. Many organizations measure it and then nobody uses the data, and that's when measurement plans usually fail. You analyze because the data you collect can't help you if you don't understand it and use it to shape your decisions. So it costs money to collect data. If you're just collecting data and not analyzing it and using it, then you're not getting any of the benefits. Again, the purpose of measurement and analysis is to develop and sustain a measurement capability that is used to support management's information needs. This is whether it's needs for software development or other needs. There are different kinds of measures that can be used. Wrong way. Okay, just a few more words about measurements or metrics. They can provide a top-level management overview of the software testing status. Usually what we know about the software testing status, it's supposed to begin on one day and it's supposed to end at a certain time, and we really have no information, any objective information of how we're doing. As an example, if we used up 50% of the resources and time, have we done 50% of the job? Usually the test manager will say, we're in good shape, trust me, and that's all we really know. So what we want to be aware of is measurements can give us visibility into the testing phase. As I said, an example, if we used up 3/4 of the budget of time, have we done 3/4 of the work? What we're going to do is compare actual progress to plans, and I'll show you how we do that. And the metrics can give us early detection of potential problems. If you know you have a problem early enough, then there may be some options to solve it or go around it. If you don't know you're in trouble till the very end, it's probably too late to do anything. And what we're going to show is trends uncovered can be projected to evaluate potential impacts, and that'll be clearer when I show you some examples. And I'm going to say one more slide and then we can get to the metrics. Metrics can help answer these questions. Is there really a problem? Are we really having a problem in the system test phase? Are we going to meet our schedule? Does it look like we're going to meet our schedule, or does it look like we can't meet our schedule? How big is the problem? If we're supposed to be finished at one date, are we going to be finished weeks later or months later? Metrics can give us an answer to that. Are there any related problems? Again, I'm just going to show 2 measurements, but there are many more measurements which I'll mention as we go on. What should expect to happen if I do nothing? And there are measurements to say, is it a quality product? So that is going to be all we're going to talk about, and why don't you keep these thoughts in mind and see if you buy them or not when we're finished. The first one we're going to talk about is system test progress. We're measuring progress in the system test phase of the software lifecycle development. Now let's go over. In here are weeks. Now here is number of tests successfully passed. number of tests successfully passed. Now here is the plan. The people in the independent test system test group said this is their plan. There are going to be 50 tests which they've developed, and in the first week they expect to successfully complete 10. In the second week they successfully complete 20. In the third week here, and they should have successfully completed all of the tests in week 5. So that is the plan. Now where did this plan come from? If they had some historical data that they were saving metrics, they would have some idea of the productivity. If not, they just took the best guess they can with the experience they had in past jobs. We're talking about professionals. So this is really the productivity level. The productivity level of successfully passing 50 system tests, and when that's complete, we're ready to have acceptance tests and go operational. So what do? This metric now talks about actuals. Every time period, and here it's weeks, it could be bi-weeks, it could be months, it could be days. In the first week, the team planned to have finished 10, but guess what? They really only finished 5. So every week or every reporting period, we put in the actuals. The second week, they thought they would have 20 done, and they only successfully completed 10. In the third week, they thought they'd have 50, and they only had 15. Well, they were so far off that a number of companies with metric plans say when you're over a certain percentage from plan to actuals, you have to go back and do replanning. You're here, can you really meet that date? Well, the people in this example looked at it and said there was no way. They had planned badly. They weren't aware of all the problems. And the best they can do is this, and this became Plan 2. So now in Plan 2, this is going to be extended out. So now this is Plan 2. And by the way, when you talk about what is the impact of the new plan, the original plan was supposed to be finished in week 5, and now we may not be finished till week 8 or 9 or 10. So we have the initial plan, the actuals, the reevaluation of the work remaining, and the best estimates of the team saying, well, this is the best we think we could do. And it says we now think we may be able to do 20 in week 4, and we may be able to do, we think we could do 25. Now, if you're here, what options do you have? One option is this is what it's going to take in our best estimate. Another option be maybe having to do with staffing. Maybe we can do that if we increase the staffing by a certain amount. So maybe we can do that. Another option you have is, what if we take out a number of the requirements that are gold-plated, and we think they can be moved to a later module, and if we have less requirements, we may only have 30 or 35 tests to pass. So again, since using metrics makes you aware of the potential problems early enough, you have some options rather than wait till you're here where you may not have any options. In this case, staffing was not available. We couldn't cut down on the requirements, so the option is to go and be late on the phase. Let me continue. Now, just because we have Plan 2, we still continue to do the actuals. So here in week 4, forget about Plan 1 says. Plan 2 says they could do 20, but they really only did 18. So we're continually putting together plans 1 and 2 against actuals. On Plan 2, On week 5, they thought they could 25. They only did 20. And here on week 7, they thought they can do 35, and they only did about 28. So in reality, we really need a look here again, and another plan 3. In a lot of organizations, if you went to say plan 1 and 2, you're afraid they'll shoot you, so you don't tell anybody till the very end, and then you have a mea culpa. In many organizations, every reporting period, all the books have to be balanced, and you have to know exactly what it's going to take to finish, because you may need more time to tell the user, or you need more bucks and go back to the program manager. So again, on most of the ways people are doing things now, you could have plan 1, plan 2, plan 3, but at every reporting period you want to be in sync as to when you're going to be finished, so you can tell the user it's going to be on time or late, and you can tell the budget people you do or don't need more money. So again, this is how people use the system test progress metric. Let me go again, give another example, very similar. Oh, wrong way, excuse me. Here's some explanations. These would be in the metrics plan, where you describe what you're going to be doing. System test progress measures the ability to maintain progress during the system test phase. And in the plan, we'll say a corrective action, 20% change. Some organizations have 15. This is not standard, no standard number. Change between planned and actuals requires replanning. If you're a certain amount behind, we force you to go back and replan, saying, can you meet that original schedule, or what is the schedule you now could meet? And if we take a look at some analysis, once an actual trend line is established, it is difficult to modify the rate of completion unless corrective action is applied or the process is altered. The trend line is really the productivity. And once you have 3 or 4 data points, you know your productivity trend line, and it's going to stay that way unless some corrective action is applied or the process is altered. Now here we're only looking at one metric, the system test progress metric, but in real life there are other metrics to review which could help in analysis in the testing phase and provide insight into the problems, including requirement volatility, a measurement of how stable are the requirements. If the requirements are changing even while you're in the system test phase, that doesn't bode well. You could be looking at software size. When you made these estimates of how long it's going to take to do the system test phase in the beginning of the life cycle, and what happens by the time it got to you, the software size has increased because of requirement creep by 20, 30, 40, 50%, then this is one reason why you may be having problems. And how about testing team staffing? If you assumed you were getting so many full-time bodies, so many senior people, so many junior people, and your staffing is not what you planned, then you also have a problem. So again, when we look at each reporting period, we don't just look at the test progress measurement, we can look at all the measurements that we have been saving and producing. Again, let me give you another example. Again, this is a very large software-intense system. There are 1,200 tests, and you can see this is the trend line. Once you have 3 or 4 data points, you can extrapolate. This is your productivity curve. And as an example, in week 2, there are 300, in week 3, 500. And then we have, this is plan 1, and then we have the actuals. So we take a look, we're behind on week 2, we're behind on week 3, And in week 4, we have 500 instead of 700. We now know exactly when someone says, we're in good shape in system tests, trust me, you know that may not be so. We know objectively that we're 200 successfully tests completed behind. We planned and based all our schedule on having 700 tests successfully completed, and we only have 500. So then again, they have a replanning and a reevaluation, and the people looking at all this effort, there's no way we can increase the productivity by that amount. And usually the reason these things are off is because most the test planners don't have any historical data, corporate data like Siemens have, and they just have to take the best guess they can from their experience. The experience may be in an environment that's different. So here again, the test team comes back, looks at it, replans, and say, well, we can't go meet that, so now we have plan 2. So again, we have plan 1, actuals, which we compare, and plan 2. And then again, we continue with actuals. So in this case, a month later, and they said they'd be able to do 25. They only can do, about 18. They could only do about 15. And again, here, the difference is that much. And here, the difference is that much. So again, we can see objectively that at the end of 7 weeks, we're so many weeks behind plan 1, and 30 to 20, and we're 10 successfully completed tests behind from plan 2. So management has to be made aware of it. It's the 7th week, and so we probably have to replan and do plan 3. Again, nowadays I know that in most cases you don't do plan 1 and 2. If you try to do plan 2, they shoot you. So you just say, we're in good shape, and you're hoping for a miracle. And as a rule, those miracles don't come. The last thing management wants is surprise. You're going to get your head beaten, but the earlier you make management aware of the problem, maybe it won't be beaten up as much. Maybe it will. Here's a variation of this, of the data you collect for the measurement, but here we're not talking about progress. Here's a variation where it gives us an up-to-date status. Now let me go over this one again. This is the number of tests, and in the beginning we had planned to do 250 tests. And when we get to week 7, we see that because of our interpretation of the requirements, we need a few more tests. And when we get to week 8, we see we need some more tests. So this is a status of the number of tests needed to successfully complete the system test phase. And we can see we went up here, and there's some reason we found out why. Now the next one is producing the documentation from the test. Organizations have a test plan, and each test has a test plan, and each test plan talks about inputs and outputs, and what are the expected values, and all the information you need to set up the test. So when you start getting ready, you don't have to spend a whole lot of time thinking what are the inputs I need for this test, what are the outputs, what I have to set, what buttons to push. This is in the test plan. So this is the status of the documentation of the various tests. So in week 1, we've completed documentation for the first 150 tests, and in week 2, we've completed documentation for the 170 tests. In week 4, we've completed documentation to close to 200 tests, and here we're seeing that we're completing this documentation in time so that when we're ready to run the test, the documentation is ready and the test personnel don't have to start spending time figuring all these things out. Now again, the only way you're going to have these kinds of data is if you have a metrics program and keep measuring. Again, the next one is tests that are executed. Execution of these tests. In week 1, we've executed 100. In week 3, we've actually executed close to 150. As an example, in week 6, we've executed 200, and by the time we're finished, we should have executed. But again, here is not only executed, but how many have passed. We've executed many, but here we're talking about how many have passed. So now we see a complete status. As an example, in week 1, we executed 100, but only 75 have passed. So here is the difference. In week 2, we executed 150, but only about 110 has passed. In week 4, we executed, again, this is a variation of the test progress. It's another way of looking at it, and this looks at it with the view of status rather than progress. In week 5, we had executed 175, but only 125 passed. And look what's happening now. It's not getting any better, it's getting worse. We executed 100, but we only passed about 130, and here's the problem. We've executed all of them here, but only 200 have passed, and the problem is there's all this rework to do, which has an impact on schedule if you haven't been able to add more people or cut down requirements. We're talking about rework greatly affecting your completion schedule. And here we have the status where every way along the way we know exactly in an objective fashion what's going on, rather than the test manager saying, we're in good shape, trust me, hoping for a miracle at the end where he can come out swelling sweet. And as we know, miracles usually don't happen. They may happen to other people, but they haven't happened to me. Okay, so that's a review of one of the important measurements that we have in the system test phase. I think of all of the measurements, this is one of the most important ones, and one that many organizations who have metric plans have used and are beginning to use. We're going to talk about a second one, and the second one is incident tracking and measurement, or some people call problem reports, keeping track of them in an objective way so we know exactly what's going on. And the definition from the IEEE is software test incident, any occurrence during the execution of a software test that requires investigation. So let's go on and see how we would do the measurements for problem tracking or incident tracking and management. The standard way is here. We're talking about the time frame. This is a reporting period, could be in months or weeks or days or whatever your organization does. And here we're talking about fault profiles, the number of incidents we have, the number of problem reports we have. And by the way, all problem reports aren't the same. Most people would do this for highs and mediums. Many organizations have 3 priorities of faults: high, medium, and low. And the ones that are important, of course, are the high and the mediums. So here's reporting of the number of high, as an example, and medium problem reports. And here's the time frame. And here we have the total number as we're going. So this is the total number. In February, we've reported 50. In March, we have 100. In April, we have about 150. In August, we've reached the top and we have 300 reported. So here, with this trend line, and as we were getting closer to system test, they should still go up a little bit, but in some way, as we're getting closer to system test, they should be plateauing. If it's keeping going up, then we can see objectively that we'll have a serious problem with meeting the deadline for system test and turning over for operational. And now we have here the second one, those that are open. As we're going along, we're finding them and hopefully fixing them. So as you see, as these are going up, these are open, which means the ones between here and here are ones we fixed already. And in August, there's maybe 100 open, and we've closed 200. And as we're getting close to turnover, this should be coming down. When we get to be turning down, we should have closed all of the highs and mediums. Many organizations have rules saying you can't go into operational test operations without fixing all of your highs and mediums. If you're getting close to operational, going operational, and this hasn't plateaued, and this is not coming down, then you know you have a serious problem. Let's go on. And what I have here, excuse me, take a drink. What I have here is a real chart from the real world. This is not one that was made up as to show good, clear examples. This is from a project that was extremely late, over budget, did not meet the schedule, caused a lot of grief. And again, here we have the time frame, and notice I've went 2 days, day 1, day 3. As you're getting later and later, you want more and more granularity. You don't want it bi-weekly or weekly, you almost want it every other day. And so I got a report from this way. And here are the number of the kinds of faults or bugs or incidents we're talking about. And again, the program manager in our reporting period every month comes and gives a brief and says we're close to turnover, 3 weeks, and everything is in good shape. And when you evaluate this thing, what hits you right on the head? How could you be in good shape with this kind of data? That all of a sudden, take a look at the steepness of the bugs, and this is the closed, and this is the open. How can we be in good shape if the trend line is going up? Notice what's happened. The trend line was going up, and they plateaued, and they thought that was going to be it, and then all of a sudden the trend line went up again, and it plateaued, and the trend line went up, and every time it plateaued, they'd find more. How do we know this is going to plateau and we're going to be in good shape for turnover if it doesn't start going up again? And notice what happens to these yellow ones. These are closed. And by the way, these are open, and of course the difference between open and closed. So here we are, it is going up steep, but in the beginning you do tend to find more errors. But as we're finding errors, the closing is, we're fixing them in very well. So we're finding and fixing errors very well until we get to here, where now it's taking us a little longer to fix the errors. And here it's taking us a little longer to find and fix the errors. And take a look from here to here, and from here to here, and mainly from here to here. We've hardly been able to close any errors. Are those people all away on vacation? Is there nobody fixing errors? There seems to be no progress in closing from this period to that period. So because we have this data, and not just the program manager saying, we're in good shape, trust me, we can ask detailed questions. Explain to me what's going on here. How come nothing is being closed? And of course, these are going up. What is going on here that is not being closed? And of course, how could you give me any good feeling that you're ready to go operational if this is still a trend line like that? And finally, we got the answer to why this is happening, something I had never seen before. What happened is when the team that is finished with the unit testing and getting ready to turn it over to system testing or black box testing, the corporation started bringing some of these programmers off and moving them out, thinking the project was of high quality, and gradually taking people off the project and moving them to new projects that are starting, figuring we're in the testing test phase. The quality is good, so we don't need these people now. And they moved so many of them off, and they left such a small maintenance team that when the problems kept going more and more, the people who wrote the programs weren't there to find out where the error was or knew what the programs were doing. We had a small maintenance team that wasn't familiar with the programs. They had to even go back and get the documentation and get the listing and going. And it took such a long learning curve that there was very little progress in closing. And there was no indication how long that learning curve was and when that would improve. But the important thing is, of course, the project was in bad shape, but without this metrics data, we would not be able to inform management about our concerns, about the problem with schedule, and about the problems with budget. Again, we're usually doing with subjective evaluations. We're in good shape, trust me. Coding is coming along fine. Testing is coming along fine. And now we want to go, and measurements give us objective data. We know exactly, we had planned to successfully test 200 tests, and we've only done 150. We're 50 behind. So the whole value of measurement is to go from subjective data, which are basically no more than opinions, to objective data, in which you could make some decisions with. And when you have these measurements for problem reports, there are many others you can work with the same data. You can now get the difference between high, medium, and low priority errors. You can do root cause analysis or problem report classifications. These are the problems, and you can break down into logical areas. We have so many problems in the area of performance. We have so many problems in the area of logic. We have so many problems in the area of interfaces and some other miscellaneous. And people can go back for historical purposes or even now and find out how come we're having so many more errors in performance. Is there something about the requirements or something about the design that caused this? And again, this will be data, historical data, that can be saved as a corporate asset. So what we can say is incident fault measurements provides insight into the quality of the software development effort, as well as the developer's ability to fix known bugs, plots the number of problems and the number of open problems against time. And you have to remember that open defects represent rework. Just like finding all those errors in system tests, meaning rework, and did you budget for 50% of the errors in system tests? If you didn't budget, just the rework would have a problem with schedule. So open defects represent rework, and defects provides insight into the project maturity. If there are a lot of defects, you have some concern about maturity. A large number of open defects may be a leading indicator of future budget schedules and slips. And we're going from subjective measurements, which are opinions, to objective measurements. And what we're saying is defects should be tracked throughout the life cycle using a single defect tracking system. And we now know that defect tracking and the measurements involved is an important component of a successful development effort, as well as an important source of data for software process improvement group, as well as for collecting history for future estimations. Now I've gone over the two measurements and some talk, and let me just end this by talking about metrics benefits. I don't want to oversell metrics. Metrics by themselves do not control or improve anything. A lot of organizations collect a lot of metrics and they never use them. In fact, that's the best way to fail. Costs money to collect metrics. If you're just collecting them and nobody using them, why should anybody care to expend effort to make the quality good? So if you just collect them and don't use them, they don't do anything for you. But they do give insights for planning, managing, and as a basis, objective communications. We don't have to say, that's terrible, that's no good, you guys aren't doing any good. You now know that you had planned to finish 200 successful tests, but you only completed 150. You now can decide what options you have with that objective data. And of course, the metrics data is kept as a corporate resource. Historical metrics data helps estimation, predictions, and planning for future projects. Future projects could take a look at your system test measurements and take a look at the productivity of something similar and see how long the productivity curve is, and we'll get some insight. And what we're talking about is actual versus planned data helps determine progress and supports decision making. We're not doing something very complicated or very confusing. In most cases, in many of the metrics we're doing, we're keeping track of the planned data and the actual data. And that's what gives us the objective information we need. Okay, one more slide. Measurement summary. Again, I've only given you two measurements, but keep in mind in the test phase and in the one-day tutorial that we give, or that I'm going to be giving at that conference that was mentioned, we talk about other measurements that are used in the system test phase. We're going to be measuring software stability or volatility, which means how stable are the requirements. If the requirements are changing all along, we're talking about software size. If you made your estimates on system test when there were so many lines, estimated lines of code, and now it's 30% larger, that's going to cause a problem, so you have that metrics. And we're talking about system test staffing. If you thought you were going to have X number of senior testers and X number of junior testers on your staff, and you have less, staffing measurements give you track on that. So when you look at every reporting period, you don't look at just the two measurements that I've gone over. You look at a half a dozen or up to a dozen other measurements, which I talk about in the full-day seminar. So let me just say, software measurements has evolved into an important software engineering discipline. It is now a software engineering discipline worldwide. It is now considered a basic software engineering practice, as evidence is an inclusion at the level 2 maturity requirement of the Software Engineering's Capability Maturity Model Index, which is used as a maturity model by organizations all over the world. Well, again, thank you for joining me. And now, if there are any questions, I'll be addressing them. And thank you very much for attending.
Thank you, Al. It looks like we do have one question there if you want to take a look at that.
What is the difference between fault? Okay, good question. What is the difference between fault origin and fault detection? Fault origin is the phase in the life cycle where the error was put in. As an example, it could be put in the coding phase. And fault detection is the phase in the life cycle where the error was detected. And as an example, it could have been detected in the system test phase. You may have a fault origin, an error put in the requirement phase, and the fault detection is what phase do you find it? Did you find it in the requirement phase where it's cheap to fix? Did you find it in the design phase where it's more expensive to fix? Did you find it in the system test phase where it's 12 times more to fix than you found it in origin? Or did you find it 2 years later when you're in operation, in the field operation? Then, good question is where you put it in and where it was found. And we all know that the earlier in the life cycle you find an error, the less expensive it is to find and fix. The worst case is to make and to put in the error in the requirements and to find it out in the field. And in Siemens' case, it costs 20 times as much to find it in the field as if you found it early. That's the whole rationale behind modern programming practice, where we try to spend more effort up front to find it earlier because it's less expensive to find and fix. I hope that clarifies it. Any other questions?
Thank you, Al, for your time today, and thank you to everyone for joining us for today's webinar sponsored by IIST, the leaders in education-based certifications and training. For more information on how IIST can help you or your organization, please visit www.iist.org. You can follow IIST on Facebook, Twitter, LinkedIn, and YouTube to find out more information about IIST news, events, and promotions. Thank you all again for joining us today, and have a great day.